Okay, so I asked you to do numbers 1 to 5 on this sheet that I gave you the other day. Oops, not that sheet. There we go. So number 1. Number 1 says a net force. So I was trying to make life easy for you, and I gave you the net force. So not the F, and there's not a friction. I actually already added the force you're pushing with and the friction up, and I got a net force of 25 meters, and it's applied to a Newton, and it's applied to a cart which weighs 125 newtons. Weighs is Fg, so I'm giving you the Fg here, 125 newtons, and it wants to know what's the cart's acceleration. Well, we know F net equals ma, so we can find a by doing F net divided by m. Divided by m. So we have the F net, it's 25 newtons. What we don't have at the moment is m, but we can get it from Fg, because we know Fg is equal to mg. So m is going to be Fg divided by g. So 125 newtons divided by 9.81 meters per second squared. And so you'll get an m of 12.7421 kilograms. So then over here you'll put 12.7421 kilograms in for m. And when you do, you'll get an A of 1.962 meters per second squared. And that's it for number 1. Number 2 says, what force must be applied to a 60 Newton object? 60 Newton object, again, is the Fg. So I'm telling you the Fg is 60 newtons. Of course, there's a normal force going up. So from this Fg, we can get mg, right? So Fg is equal to mg. So m is equal to Fg over g again. So 60 newtons divided by 9.81 meters per second squared. So we can get our mass to be 6.1162 kilograms, okay? So I'm finding that because I'm assuming we're going to need it. So if I continue to read, it says, what force must be applied to a 60 Newton object to accelerate it at a rate of 3 meters per second squared if the force of friction is 5 newtons? So friction is 5 newtons. And the acceleration in the x direction is 3 meters per second squared. So normally we would start and we would find Fn. And we find Fn because we want to find our friction and with our coefficient. But in this question, they give me friction, and they don't ask me about the coefficient, so I don't need to do some of the forces in the y direction. Who cares about the normal force if I don't need the mu and I already have friction? So I can just go to some of the forces in the x direction. And in the x direction, there's F minus friction is equal to max. And what are they asking me for? What must be the force applied? So I'm looking for F. So F will be equal to max plus friction. Well, we found our m. It's 6.1162 kilograms. A was 3 meters per second squared. And it tells me in the question that friction is 5 newtons. So this is going to be 18.3986 plus friction 5 newtons. So I should get 23.3486 newtons. Okay, number 2. Number 3, a 5 kilogram box, so here's my box, it's 5 kilograms, is being pushed along a horizontal floor by a force of 25 newtons. So F equals 25 newtons. Fg, of course, is acting this way. Normal force is acting up. The force of friction which opposes this motion is 10 newtons. So friction acting backward, 10 newtons. If the box started from rest, so Vi is 0, what will its speed be after 5 seconds? So we're wanting Vf when delta t is equal to 5 seconds. So to find the speed, I'm going to need A. in the x direction. And I can get A in the x direction by looking at the sum of the forces in the x. Okay, so again, I don't have to do my y to get my Fn because I already have friction. So I don't need Fn to do mu Fn because I already have friction. So F minus friction is equal to max. So A will be equal to F minus friction divided by m. So 25 newtons minus 10 newtons divided by 5 kilograms. On the top is 15 divided by 5, should be 3 meters per second squared. So then I go back to kinematics and say, well, I know A equals Vf minus Vi over delta T. Starts from rest, so Vi goes to 0, so Vf is just going to be equal to A delta T. So Vf is equal to the 3 meters per second squared I just found, times 5 seconds. I get a final speed of 15 meters per second. So the good news that you may have just realized here is that the kinematics equations will just keep coming back up. You never finish with them. Number 4, how long does it take? So you're looking for a delta T. How long does it take a net force? So again, they're giving you a net force. They're not telling you you're pushing one way and friction is another. It's a net force of 100 newtons acting on a 50 kilogram object, rocket, to increase its speed Vi from 100 meters per second to 150 meters per second. So again, we need an A, and luckily we can get it because we know F net equals ma. So A is equal to F net over m. So 100 newtons over 50 kilograms. A is equal to 2 meters per second squared. And then we go again to our A equals Vf minus Vi over delta T. This time we're looking for delta T, so it's equal to Vf minus Vi over A. So delta T is equal to 150 meters per second minus 100 meters per second over 2 meters per second squared. On the top is 50, 50 divided by 2, 25 seconds. Okay, number 4. Number 5. What braking force is needed? So braking force is going to be, if this is the direction of motion, then braking force is going to be this way. Okay, and I'm going to put it as BR for braking. Fg is going to be acting down. The normal force is going to be acting up. What braking force is needed to bring a 1,500 kilogram car moving 30 meters per second, so Vi is 30 meters per second, to rest, so Vf is 0, to rest in 5 seconds, delta T is 5 seconds, after the brakes are applied. Okay, so when your brakes are applied, it's really like the combination of brakes friction that slow you down, so it's combined into one force here. There's no forward force because you should never try to stop with putting your foot on the gas. Okay, so first we can find our A, doing A is equal to Vf minus Vi over delta T. So A is equal to, Vf is 0, so negative 30 meters per second over 5 seconds. So A is going to be negative 6 meters per second squared, where the negative, of course, means slowing down. So now we can do sum of the forces in the x direction is equal to max, and the only force in the x direction is the braking force. Okay, and that's equal to max. So the braking force, whoops, it should be an F with a B, is equal to m, 1,500 kilograms, times A, negative 6 meters per second squared. So F braking is going to be equal to, what is that, negative 9,000 newtons, where the negative means opposite motion. So these ones may have messed you up a little, which wasn't my intention. They were actually easier than the ones we were doing in class because you didn't have to do some of the forces in the Y. but they're coming. I promise they're in the next set.